Hello, I'm Julian Barros, a PhD student at the University of Mississippi, and I'm presenting my study with the title Performance Prediction Model for Flexible Pavements in Mississippi using Neural Networks. The objectives of this paper were to analyze roughness data for flexible pavements in Mississippi, develop pavement performance models for Mississippi road networks using the artificial neural networks approach, most known as ANN, and perform a sensitivity analysis for a random section of the Mississippi road network. The methodology of this study is shown in this figure. The first step was to get the MDOT database for flexible pavements, process the data into a modeling format, and start the data visualization with the creation of geospatial maps, correlation plots, and statistical analysis. After this, further investigations on the input and output variables was done to start the pavement performance model using a machine learning technique known as ANN. And in this study, a special case using a dynamic sequential ANN was used in the study. The data collection uh, started using data collected from 2010 to 2020. However, in Mississippi, the distress data is collected every even years. So for this reason, the odd years were generated by averaging consecutive years. A total of almost 36,000 data points and 4,000 flexible pavement sections were used in the model development. It is known that Mississippi did not keep track of all rehabilitation actions, and for this reason, a minor and major rehabilitation threshold approach was proposed in this study. Three models were developed in this study with 16 independent variables and 3 dependent variables. Model 1 used complementary PCR, Model 2 used IRI mean, and Model 3 used the two-output model with complementary PCR and IRI mean. The ANN model development used 4 different stages to try to find the best model by selecting them with the lowest average square error, lowest mean absolute relative error, and highest coefficients of determination. We can see in the first table for the complementary PCR, Model 3 showed much better results with an R-square of 0.9 compared to an R-square of 0.6 for Model 1. In the second table, we can see that for IRI, Model 3 was slightly better than Model 2 with an R-square of 0.4. The ANN model results show in the first figure for the PCR value that the Model 3 predictions clustered around the line of equality and show that the PCR behavior was captured by the prediction model. For the IRI values, predicted values were closer to the line of equality just when the observed values were between 0 and 2.5. When they were greater than 2.5, the model could not capture the behavior and underpredict the roughness value. That's why we have an R-square of 0.4. However, the model can be considered highly accurate because it's really hard to get these complex relationships between all the variables. A sensitivity analysis was carried out to evaluate the performance of the developed models. We can see that predicted PCR values were very close to the observed values, which showed the PCR trend was captured by the model. For the IRI mean values, the values follow the trend with the actual IRI data increasing with the time, which showed that the model was able to understand the deterioration behavior, but over-predict most of the values. Therefore, we can say that this study successfully developed the performance model with a higher R-square for PCR of 0.9 and a reasonable agreement for R-square of 0.4 for the IRI outputs. Also, the sensitivity analysis showed that the developed model was accurate when predicting both PCR and IRI. Therefore, the MDOT can use the model as a tool for predicting future conditions of asphalt pavement sections and incorporate the maintenance and rehabilitation scheduling effectively to prioritize the resources. Thank you.